I've got this mirror, it's about 1 foot diameter, resting on this metal ruler on a platform here, and the other end is on the balance plate. And so in this setup, it moves around a bit. So it's currently reading about 580, 590 milligrams. Now watch what happens when I turn the light on here for a bit. I'm going to have to do this quick because it's a short video. Okay, so the light is on just above the mirror, and you'll see what happens to the readings. I'm going to have to pause here, come back. So they're going to start going down, saying 605 right now. The reason I want to do a mirror is because this minimizes absorption on the surface and heating, and also these are white LEDs, so the thermal content is very low. You can see it's going down to 459, as if it's being drawn upwards towards the light. 440. It takes a few minutes for the system to respond. And now I'll turn the light off, just for the sake of time here. So the weight should come back up to where it was. $450. I've actually seen bigger results with the calibration weight here. This 200-gram calibration weight. Notice how polished that is. So most of the light's going to be reflected off the surface. But if I put it on here instead of the mirror, I've seen much greater swings, which I can demonstrate too. So that should just keep coming back up a little bit to where it was. I'll try the calibration weight next. Okay, I'll try this. So watch what happens. The reading, it's hard to see because of the contrast, but it's reading minus 120, 140, 150. It's just dropping like crazy right now. Minus 240. It's just putting the light over top of the calibration weight. Minus 350. Now we'll take the light away. And that should go back up towards 0. I'm just going to pause here. Yeah, I just want to pause for a minute there just to save recording time, but it's slowly making its way up towards 0 again, where we started. It does that when it's changing rapidly. So again, just addressing the idea of thermal heating errors or whatever may come to mind. These are white LEDs, so there's very little, radiant heat content in the light, and that's a highly polished steel surface. So that would mean a very, I'd say, very negligible heat absorption. So I think I've solved one of the mysteries. I have this set up here. I've been quickly testing. This is just an aluminum pipe, and inside there's a 500 gram calibration weight right around here in the middle. As you can see here, there is a tiny gap. So the edge of this pipe is resting on this plate, on this platform. On the other end, you can see there's a tiny gap. So the edge of the pipe is about right in the middle of the balance plate. It's currently tared to 0. Right here is a 35 watt LED panel powered by this 12 volt battery here. Small gap. Now what I'll do is I'm going to turn off this big light up here, and then I'm going to turn on the LED panel. So that's actually going negative because I can't really see it. Anyway, so what I'll do is turn this on. And just watch what happens here. See how it's like gaining weight and then off. I've been trying to figure out what's actually going on here and how it works. $36 milligrams. I tried the LED panel with nothing attached to the balance to see if just having this on would affect this, and it didn't. So I know it's related to having something set up like this where it's measuring weight. In other words, the light has no effect on the balance in and of itself. So off. Now that'll go down towards 0 again. And the big reason why it's slower going down is this. This is very interesting. You see the panel there is reading about 22 degrees Celsius and the surroundings about 10. So this panel is emitting infrared light while it's cooling down, and that is contributing to the force effect that we're seeing. So what's actually happening here is the radiation coming off this panel, whether it's visible light or infrared, is basically coming upwards vertically, but it's being reflected off this pipe, and the rays are being redirected outward. So why that's important is it creates an asymmetry in the direction of the light. If I use a flat plate just above the LED panel, there's actually no change. There's no change here. So it's as if this has no effect, or the light has no effect on the plate, but the plate is reflecting the light, so it's like it cancels out. Now what I'll do is take this up to a maximum here with no calibration weight in here. When the pipe was just empty, I got it up to 0.2 grams. So let's see how high it goes with the weight in there I want to see if there's a significant increase here. Yeah, already over 0.2. I'm just going to pause here because my memory is low here. I'll come back if this goes to 0.3. So over 0.3 now. Oops, just touching this panel here. It just feels slightly warm. And unfortunately, I just bumped the tube. So yeah, this is screwed up now. But still increasing. Just went over 0.3 again. I haven't touched it or bumped it. 0.4. Okay, it's slowing down here, approaching 0.5. I'm going to turn it off. We'll see the weight drop, and I will measure the surface temperature of the panel. So it's reading 38 degrees C. And that'll take a little while to cool down. And weight is dropping. In other words, the downward thrust is diminishing, and this is going to go back to equilibrium again, and this will approach 0.